In the primitive era, there was a shepherd who sat at the entrance of a mountain cave every day to watch over his flock. In the morning, when he led the sheep out to graze, for each one that came out, he placed a stone, and for another that emerged, he added another stone. This continued one sheep, one stone until all the sheep had come out. In the evening, as a sheep returned to the cave, for each one that went in, he discarded a stone, and for another that entered, he threw away another. Thus, it was one in, one stone discarded, continuing like this until all the stones were gone, which meant all the sheep had returned. Here, each sheep corresponded precisely to a stone, exemplifying what is known as one-to-one correspondence. Simply put, it's one-to-one. Using this method of one-to-one correspondence, many problems can be solved. For example, consider two groups of monsters engaged in a battle, with each monster having a number on its head representing its combat power. Which group do you think would win? On the left, there's a monster with a power of 5, and similarly, one on the right. After they fight, both are defeated. Then, another monster with a power of 5 appears on the left, and another on the right. They fight again and both fall. This continues 5 versus 5, 50 versus 50, 12 versus 12, 21 versus 21 until finally, the right side has one monster with a power of 5 remaining, while the left side is wiped out. Clearly, the left loses, and the right wins. In such scenarios involving groups of 5, one-to-one correspondence resolves the outcome. Beyond comparing numbers, one-to-one correspondence can also compare monsters. Similarly, even cakes that appear roughly the same size can be compared using this method. Look! There's a green parallelogram on the left and a green parallelogram on the right. Let's eat both together. There's a blue square on the left and a blue square on the right. Let's eliminate those two. By pairing cakes of the same color, shape, and size, we systematically remove matching pairs. In the end, if the right side is finished while a square remains on the left, it means the left cake is larger. When cakes are colorful, it's easy to find matches. But what if they're all the same color? In that case, ignore the color and focus on pairing by size and shape. Mark off matched pairs with an X, and then compare what's left. The remaining part reveals a larger one. This is how one-to-one correspondence works for comparisons. Do you understand? If so, hurry and start drawing X's to compare sizes.